and aimed at those doing seabed projects offshore. And FM Pro up until now includes everything, so that was in the package. Going forward, as Aaron mentioned, we have Midwater, which is going to be an add-on module for everyone. It's not included in Pro. And then ArcGIS, the integration is only a Windows app module or functionality within the software, and that'll be included in Habitat and Pro. One of the things just to talk about briefly is we have a large variety of users and uses, and I'll talk about that in a minute. And then as we move on, the first questions, and really before you move into the workflow, is, what type of data or the amount of data do I have, and what do I really intend to do with it? So as opposed to a software that just does one thing, either acquires, sonar data or processes multi-beam data or, processes side scan, there are many uses for the Fledermaus suite, and that's increasing as we have now backscatter processing, the water column data is beginning, and so there's an end-to-end, and what that means is we have a variety of users in different places, and you all probably come from different backgrounds and use the software differently, from geoscientists doing habitat mapping, surveyors, data processors, people just using it for education in a geology course. And the uses also vary, from obviously multi-beam processing and QC, the geospatial aspects of that, visualization, backscatter processing, analysis, interpretation. So again, those are the things that really define how you might use the software and the workflows that you take. What type of data do you have and what amount? I mean, mostly I think people in Fledermaus from the very beginning were using surface, gridded surfaces, and that's where we began, and then those are still a primary data object. But to get to those surfaces, you either have to have a gridded data set, or you have ungridded data which you grid and bring into the Fledermaus environment. But there are, of course, lots of other data supporting ancillary data, which is images, whether they're for draping or they're charts or maps or aerial photographs. And there's also vectors with points, lines, polygons. DXF files are now, with the integration to Arc, the full exposure to their data types and objects. Then you've got to look at, I think, do you have just a few objects you want to visualize, or do you have lots of data that you need to really manage? The other thing is, does it cover a large area and a large variety of files, and how do I need to manage that? And you can see on the left just a very brief look at a Fledermaus scene data objects list with 3 objects. Obviously very simple and a few objects, and we'll look at that scene. Whereas on the left, in the middle there, is a DMagic source data list, which includes the various data, ungridded, grids, images, and vectors, but within each subsection of those, you can obviously add a large variety of those. I'll also show you later on the right is just the standard Windows Explorer or Finder in a Mac that shows the structure that we now put onto our projects with DMagic to assist in that project management and the data management once you start building your scenes and objects. So the other thing, again, is what do I intend to do with the data? Is it just a simple analysis and interpretation? Do I want to process and do quality control of multi-beam? Am I really processing, or am I receiving a lot of data that I need to review and then verify and populate a database? Am I doing it in monitoring a major seabed site survey with a geohazard analysis and interpretation? And do I need to generate products or even deliver my project in the Fledermaus scene files to my client? So that's something else that you may want to consider in working out which path you might want to go. So the simple workflow is, as I said before, the demand from from the client base, which probably includes some of you guys, is those that really just want to get in and look at something quick. They wanted a simple workflow with not having to go through a number of tools to get to just the visualization. And this is mostly the use of Fledermaus now for both import and analysis. So being able to just open the one application and import the various types of data and get straight to what you need to do in Fledermaus. As I said, the other end of the scale and request we had was when you get into very complex organizations and projects with lots of data, people tended to always very carefully manage their data, and they put on us that we really needed to have some structure like that within the Fledermaus suite of tools, and we chose to then upgrade the DMagic module to be able to do that, and that was for really source data management and overall project management in a geospatial sense as well. And then obviously the analysis and processing is still done predominantly in Fledermaus. So as an example, for a simple workflow, you might have a number of grids in an area where you are looking at data. You might not be doing surveying, but you want to do some analysis, whether it be habitat mapping, or you're a geologist looking at an area, and someone is going to provide you with the data. So you might have grids that have already been generated. You may have some ungridded XYZ data, XYZ data that you've downloaded from the web that you need to get in. You can do that directly in Fledermaus now. Once you've got an image of some side scan, you might want to drape that onto a digital terrain model. Do that directly in Fledermaus. You want to crop an area or mask out a surface, and again, directly in Fledermaus. So when the goal is really that one-off area, you want to be able to quickly get in and look at that, grid some data quickly for QC or checking. You know, you're out on a survey, and you want to just have a look at a quick area. Are there any tide busts? Am I really in the right area? You can certainly do that very quickly within Fledermaus, and that's one of the things we think that make Fledermaus a useful tool. It is very easy to do that and get it in. However, if you've got lots of source data that, as an example, and we'll show you, use the shallow survey data set from the Portsmouth Shallow Survey Conference in 2005 and 2001. There's a lot of survey data, and it's different types of data, and you want to keep a track of it and want to know geospatially where that data is located. Then use the DMagic tool to manage that and prepare it for Fledermaus. It gives you the opportunity there to be able to see geospatially where your data is. You can plot it to look at cell sizes, look at the coverage. This is where you do, for the hydro and processing folk, build your PFM data set the Q parameters initially, run that area-based editing initially and set it up. If you're editing imaging, this is one of the areas that we never edit the source data, except in one case, and that's with the images. If you need to crop an image, resample it in preparation for use in Fledermaus, you actually can edit images. If you've got an image that has no georeferencing on it, you can add that and save a geotiff. So this is an area where we really only edit the original source data. You can also manipulate grids here if you want to resample, interpolate, and for many people involved with, we know with using Fledermaus suite of tools, it's a place where they can also export data. So if you've got to deliver an ASCII XYZ file of a grid or ungridded data as part of your delivery, those tools are also within DMagic. So fundamentally, if you want, your goal is to have an organized project with lots of data, and you want to see a geospatial organization of that, and then build multiple visualizations within Fledermaus based on that project, this is where you use the DMagic module to start. One thing just to mention, this is related, but it was a major change that now we have the full georeferencing libraries from the EPSG with and using the Proj4 libraries for transformations and reprojections. But you just need to think about the differences when we refer to georeferencing within a DMagic project and then in a scene within Fledermaus. It is exactly the same for the objects, but within DMagic we're actually setting it for the project. So then as you're working through all your source data that might be from different georeferencing, or you need to apply it and set the georeferencing, when you're working within the project, any SD file created then will go into that project georeferencing. Within a scene has display georeferencing, and what you do with that is then you can bring in multiple objects of different georeferencing, and then it's how they're displayed and saved in the scene. So similar concept, but slightly different, and you just need to be aware of that when you're using the software. For the source data that comes into DMagic, and like ungridded data, grids and those sort of things, the benefit of having it through DMagic is we provide a link within DMagic then, and we'll show you that, and it creates a little metadata file that gives you information now about that source data. It gives you the bounds of the source data, and if that source, if you're working in a project in UTM Zone 19 and you have data that is a WGS84 geographic data, the bounds of the source data are reprojected and shown within DMagic, and we'll show you that. But it sets the georeferencing you have in the project, sets it when you convert it for an SD object. You can also within there, if you've got, as I said before, if you've got an image that has no georeferencing, you can apply that within the image editing aspects and functionality within DMagic. Within the scene, that's a scene-focused georeferencing, and it's for display. On loading the first object into the scene will take that georeferencing from that object and keep it then for the scene unless you change it. There's two things you just need to be aware of here. You can load objects into the scene that have different georeferencing from the scene. So they can, if the scene is a UTM projected scene, you can load in WGS84 geographic data, but it will depend on the type of data what happens to it. If it's a raster object, a grid or an image, it won't display, but now there's a warning that says this data object is undisplayable, and the 3D bounds of that object, a box will appear where it would display if it was projected into the scene. Okay, the second type, vector objects like points, lines, and polygons, they actually get projected on the fly into the georeferencing of the scene. So you'll actually see those as well. But natively, the object stays in its original form. For the raster objects, there is a reprojection to the scene that allows you to take it directly into the scene. And if you're then going to work in other georeferencing frameworks, there's a tool that can georeference it back into that other system or georeferencing system. In addition, when we export out surface objects to Google Earth, it doesn't matter what georeferencing system you're in, they automatically get reprojected into the Google Earth WGS84 coordinate system. So you don't have to worry about that anymore of going back complicated, saving something and then exporting it out. Okay. So, Aaron, if there's any questions, I'll take them now. Otherwise, move on to the Fledermaus and start a demonstration of some of this.
Does anyone have any questions? If you do, you can raise your hand now. Brad, we saw your question. Brad Harriet asked, when is the functionality coming for JPEG 2000 and other large image sizes? Brad, Josh in support is just checking that, and he will let you know momentarily. If anyone else has any questions, raise your hand now. If not, we'll move on. All right, Lindsay, I think you're good to go.
Okay, good deal. So, as I said, this is not a Fledermaus or DMagic webinar. It's really an introduction to show you those flows of where to get started. And as Aaron said, for those that want to see more detail, there is a Fledermaus overview and a DMagic overview separately and other webinars, or just give us a call if you need any specific things. Okay, so this is just a scene that I've started of the Portsmouth Common Data Set, and what you're seeing is a raster image. It's just a crop of the chart within the Fledermaus area, in the Portsmouth area, in the Fledermaus scene. That's the only one visible now. If I go back to the scene coordinates, as I was saying with the georeferencing, this is the scene display coordinate system. It's WGS84 UTM Zone 19 North. Okay, and if I look at the object itself now for the raster object, you'll see if I look at the georeferencing, it has a matching georeferencing coordinate system. If I now just turn on this object, and you'll note that within Fledermaus now, you'll see that it tells you it's a line object within Fledermaus, and I'll turn that on. This is a coastline that's actually been extracted from an S57 file that we've downloaded from NOAA, and it is a line object, but again, as I was saying, it's actually a WGS84 native SD object, but it's projected on the fly within Fledermaus. So it's a line object vectors because we can get projected on the fly, so you don't have to reproject those to the scene. If I just turn off the raster chart, you'll see that this object is showing red and saying it can't be displayed. And if I go into the georeferencing, this is actually a DTM object, and it's a WGS84 grid. So what you get within Fledermaus is a bounding box to show you where that object would display within the Fledermaus scene. So what I'm trying to say is, before, if you had objects that were different georeferencing, you had to prepare all that independently of Fledermaus before you even got started. Now I've loaded that grid up, it's the wrong object. All you have to do now is, if you see, let me just open that window up slightly, as you'll see in this, for that object, it's saying it's WGS84, but down the bottom here is a button which says, I want to reproject that object to the scene. And all we have to do is hit that button. The object is now being reprojected into UTM zone 19, and then the grid appears. And now, if I look at it, it's got the UTM zone 19. The other thing to note in the intro, it has an asterisk against it now, and that's because the object has changed, and it's telling you you need to save that object. So what I can do now is say, let me save that object, and I'll right-click, it's in here, and I'll call it UTM. And when that's saved, you'll see the asterisk goes away. And so now, if we look at the data sets, we have it all gridded, and we're all in the same scene object. So other things we might want to do is, now we talked about being able to import data directly and do things. So one of the things we might have, and we've already have it prepared, is there's a backscatter image that was done in Geocoder that we might want to bring into the scene and drape. Okay, all directly within Fledermaus, we can say import an image. So under import at the top, for those that used version 6 that was never there, basically now all of the different data objects to be brought in directly. So we're going to import an image, and from this sample data set, this is Kongsberg EM3002 as a mosaic that was already built, and we'll load that into the scene. We'll see this is a flat object. It's the image in the scene. We've brought it in. It's got an asterisk. I haven't saved it yet. So that would be, if you want to keep that mosaic as a flat image within Fledermaus, you would need to save that SD object. Now, when you do that, and this is where we say it was always a very uncoordinated, if you like, no structured way of saving the files, and you'll see that within DMagic it's different. You have a choice, like any browser, to choose and put that data anywhere. But what people tended to do would be put that in a place where they had their files, and so it was up to them, and it still is within Fledermaus, if you want to just take this approach, to start your folder and create your files in the one place. I'm not going to save that for now. What I'm going to do is go back to the gridded surface I have underneath, and say one of the tools now down in the panel within Fledermaus is say, I just want to drape an image onto the surface. So if I select that, it brings up this dialog, and I have the choice. I could have just got that image directly off my disk, or I can actually use one of the images that's already loaded within my scene. And in this case, I want that mosaic of the Konsberg backscatter. I've got the choice of setting the resolution of the drape, and I can or can't apply illumination. And so for this case with the backscatter, I don't want to confuse the grey shadow with the grey variations in the backscatter, so I'm not going to apply illumination. And I can copy the surface, make a new SD, or I can just drape on the existing surface. So in this case, I'm just going to drape on the existing surface. It's draped it on the surface. I can now just turn off the standard mosaic, go back to my image, and you'll see now that the mosaic is actually draped on the surface. So if I profile across that now, we're seeing the backscatter draped onto the surface on the profile. So right ready to go into our interpretation. If you wanted to use that, you can then start that, saving your interpretation, really getting straight to the analysis of the data. If you wanted to pick some particular points in a scene, go to the geopicking, put some labels here, put them into the put those into the label geopicking window, and then straight away create a point object within the scene. Oops, sorry. So again, we go back to the object. We've created an internal object. We can turn down the size of that, turn down the size of the label to a size we want. Again, move it out of the scene. Start moving those things point offset around, and immediately you're starting to build on that scene. If you want to save those objects, you can. I'll turn that off for now. If you want to then bring in, if there was another grid object, you want to bring in we know there's I downloaded a grid of some topographic Lidar data for the area, so I can bring that in. This is just a simple XYZ topo Lidar grid. So directly in Fledermaus brings up a dialog, has a guess at the type of data it is. If it isn't that ASCII grid, you have your normal selection of the different types of grid data formats that we support. It's an XYZ grid, this case. Numeric fields, you can configure those if necessary. Again, it guesses the zone of the input coordinates. If it's not in the metadata of the grid itself, if it's there, it will take and read that. If it's not, it uses the scene coordinates. We can then move on, and then it will scan the file. When I went from one panel to the next, it scans the file and says, okay, here's the range of the data, here's the data dimension. So you can get a quick view of, do the numbers look right? You still don't know whether it fits in, but then again, the output horizontal coordinate system. This is what I'm going to call it. I'm going to use the step 16 color map as default. Finish. Overwrite another one. That's fine. I've already got one on disk. And we've directly brought in now the topographic grid for that. And the normal way we can change the color map, go to a topographic color map, and start to build that scene. So we could also bring on the chart. So all of these things are now available directly in Fledermaus. You can start your analysis if you then wanted to load another object into the scene that you've built previously. You can certainly do that as well. And if we look at the data set, sorry, I'm just finding a data set I had here for the rest of Portsmouth. Objects. So this is another bathymetry survey within Portsmouth. So we've got the data set now built very quickly, easily, and you can then, within Fledermaus in the scene, start to organize that and do other things. So you, as an example, you can bring in other internal objects. So we could create a plane object within the scene. We could set the plane down at a set tidal level if we wanted to start to look at the inundation or looking at certain levels in the scene based on various levels of water. So all of those things, that's just normal Fledermaus operations. I won't go into doing more of that, but it's all easily, quickly, without having to use any other tool. And this is what we would call a simple workflow. It's not necessarily simple in your analysis, but simple to get the data in and not having to prepare data in a separate tool to get there. One of the other things that I mentioned earlier for the georeferencing was straight out of here. We can also export directly to Google Earth, and again, this is an object that's in UTM Zone 19, and it's a matter of then just setting where you want that. It does all the tiling to get a suitable object, and we can just send that straight out into saving it in that project with that base name, and we can send it straight out to Google Earth, and it's reprojecting that data on the fly into that, are written into that area. So if I go to my project there, I can look at that, and we'll see that it's been written with the associated KML files, and we can directly load Google Earth and actually find now so this is not a bad way. If you get data and you're working in an area where you're not quite sure where it came from, and you're not in control of that survey, you can very quickly have a look. If you've downloaded some data on the web, where is that? You can get it, quickly look at it, and we can zoom in directly into the area. Even though it's UTM Zone 19 data, we can zoom straight in and find the So again, a quick workflow. If you're getting that, pushing it up, you want to distribute, and you're collaborating with people, and there's the data directly in the scene. And there's our office just in Portsmouth, New Hampshire, just over off here. Okay, so that's enough, I think, for the Fledermaus workflow. Erin, is there any questions that we need to answer there?
Any questions on the simple workflow before we move on? During that, we did have a question from Laura. She said she had trouble getting larger data sets in, gridding them. There are some limitations in both Fledermaus and DMagic, and they're both the same. If you're bringing in ungridded or grid files, there's a 10,000 by 10,000 limitation, or a multiplication of that for rows and columns. I'm not sure if that's going to change anytime soon, but that is one limitation you might hit. And the second is if your resulting SD file gets close to 2 gigabytes, it will also not work. So those might be the limitations you might hit if you're having trouble. And again, DMagic and Fledermaus are the same for that. Any other questions before we get into the project-based workflow? All right, I don't see any hands, Lindsay, so you look good to go.
Okay. Yeah, the only variation on that comment, Erin, is that that we're working on that certainly for the regarding the limitation of that, and also as questioned earlier with images, and the 64-bit machines that are out there now are part of that solution, not the total solution, but they do help. And with ungridded data, if you do want to build bigger objects, you can with the PFM data type, which allows you then, it's a disk-based bin and index structure, which allows you to go beyond both those limits. Okay, now turning to DMagic, and we have the project built already just to show some of that capability. And you'll notice that there's a main visualization screen that I've just got one object showing for now, and that's just from the S57 file, that coastline file that I had before. So again, this is the entrance to Portsmouth, showing the bounds within the window. And just note, the visualization for in DMagic is really Fledermaus, and if you've ever used the plan view within Fledermaus, that option instead of turntable plan or the 3D option, this is really the same. So you are loading a 3D object, but you have the 3D controls disabled, and it's just in an orthogonal real plan view. So just one object on for now. So the SD files are listed down the bottom here that you've created that are within the project. And just let me say there that if you have lots of objects created, if you have them turned on, you're using up memory. So this is really an area similar to Fledermaus, that you can have multiple objects of multiple type, but you don't need to display them all the time. And when you turn them on or off, you are actually loading them into the scene. When they're not on, they're unloaded in the scene, so you're not using that memory. So that's the SD files you've created within your project during the preparation that I've done so far, and you'll see there's varying types in this list, and they're added as you go through. So we've gone from a standard sonar DTM grid type and images, PFM object, I built a small one, and then there was some point and line objects that came out of the S57. Now the difference is, up the top panel, this is the source data files, and there's a number of options. The primary types are the ungridded, grids, images, and vector types of objects. Now, if I just go briefly to my Finder, which is the same as Windows Explorer for those on Windows, and just go back here, this is the project file that when I start a project within DMagic, it automatically generates under wherever you have that preference set. It will create a project in Fledermaus, and this one I've called Portsmouth_UTM19 North. And it will create, there'll be a project.xml file, which you can have a look at in an XML editor or a text editor. But there's always these files. The SD files, source data, metadata, PFM, workflow, and history, which are for future work. Let me comment here about the source data. You don't have to put the source data into these directories, but it's an option for those that like the truly complete encapsulated project with all their source data together. You can move your source data into those directories and then go to those within as you're working and bringing those source data into DMagic. Why would you want to do that? Well, if you're not got them within there and then you move your project, the source data then needs to update the links to where it was. So as I'm working on this project, I actually have my data on an external drive. So if I ever should move the whole project, I want to give it to somebody, the data isn't there with the project anymore. So if part of your job is to actually deliver your data together with your project, you may want to consider putting the source data in this area. But you don't have to if that's not the goal of the way you're working. But within the SD files, you'll see this lists the same ones I had, plus I also put that latest KMZ file in there as well, and it doesn't obviously show up as an SD file. Okay, let me go back to DMagic, and in the source data, we'll start at the top, and you'll see there's ungridded data here now. They're all turned off at the moment, but I can turn on now my data. If I go to the bottom one, we looked at that Kongsberg data set, you'll see that now, if I open that up, it has subfolders, and when I turned it on, you'll see in the main view, all of those lines have been selected and highlighted in the screen, on the main visualization screen. The structure of these folders comes from wherever you have your source data. So my source data was in a folder called Kongsberg, and within it, it had 3 folders: the cross lines, the even lines, and the odd lines. So if I go from those, you'll see that it selects each of those lines, and if I open that up, you'll see it has the list of all of those raw.all files that was brought directly in as the source data here. What we're displaying directly here is we haven't done anything with the data to convert it to bring it into Fledermaus, but those source data have been scanned, and if we right-click on the object up here, we can view the metadata. So when I view that, I'm seeing the actual location of the file, where I got the file from and where it's located now. So it's on my passport drive off, and that's the file name. The version, here's the XYZ bounds of Z bounds of the data, the number of records, and if you want to look at them, here's all the other fields that are within that raw.all file. So that's a summary. and we can also look at the full source of that that's in an XML file as well. So right through for every parameter there, we can see the bounds of that attribute. So in addition to creating this little metadata file on the disk, it also read or estimated what it thinks is the center line of, in this case, a raw.all file, and this is why we're seeing now some geospatial view of where that line might be. And this, again, was one of the requests we had from people, was really, we get our data, we want to grid it, but we have no idea where it is. So they wanted to organize some data management of where we want to put it. They also wanted a geospatial view of where the data was, and this is what we hope is achieved in this area. One of the options you also have here is to be able to show the bounds of the file. I'll show you that in a sec. One of the nice things here, and why people have obviously asked us this is a nice little survey, and you could bring in the bounds as a DXF file if you had it, but clearly straight away we're seeing there's a line from these data that's off to the north. Now, that might have been a reason for that, but if you created a grid, as Aaron was talking about before, if you just created a grid with all that data, you're going to get a grid that's this big, okay, which is much bigger than it needs to be. You only really probably want the survey area, which is down here. So immediately have that saving without having to bring it into Fledermaus, grid it all, and find out I've got this line way up to the northwest. I can easily see where I'm at now to be able to just take and do what I need to do with the data I have. So that's the Kongsberg data. It's raw.all. I also have the work from the shallow survey in 2001, and this again has another survey, and this is about 6 days worth of data, and again another survey data set up to the northwest here. So again, I can look at that. I can just come in, and I know those lines are actually these ones up here, and I can select all those lines across here and see them in there. One of the things that allows you to do it, we talk about DMagic, is say, okay, with that line, what coverage am I getting? So being able to ask those questions before you really get working. So one of the options is turn on the outer bounds, and then we're seeing the port and starboard bounds of that data. We can also at this stage have a check and see, okay, what is the sort of coverage of that data? So let's plot that selected data. We can plot that line, change the cell size, replot it, zoom in a little bit, replot it again. We're getting now to see the layout of the data, the coverage of it. What sort of grid size might I want? Am I able to support a 1 meter grid? Let me update that and show that grid. Now as we zoom in, we can say, okay, is that suitable? I can get a visual representation of what I'm at with that, and it's another tool within that. This, you'll notice, brought up a panel here that shows you it's not the main visualization display, this is the plotting tool. And so once we're done, we complete out of that tool and go back. If we want to at this stage then say, okay, I just want to grid this little data set here, I can do that. We won't do that for now, but again, this is what allows you to do that sort of thing. One of the other areas, so that's ungridded data, we can turn off that. There's also Lidar data. This is a bit funky because it's actually LAS data, and usually we get that per line, and we've tried to estimate the center line of the data, but in fact you'll see it's been done based on grids of data, and so the line object is a little strange, but it shows each file is a set of the Lidar data. And I'd taken a section of that before in the grid that I imported into Fledermaus, selected across that data and said, okay, I just want to grid that data within that area of the selection there. So this is one of the real benefits that you gain now in Fledermaus. You can load all those data on, but if you want to come down and you want to just get, say, to not the Lidar data, you want to come down to the data here below, and you say, okay, well, in that Kongsberg data, I just want to grid the raw data, and not only just want to grid the raw data from the odd lines, I just want to grid it around this area. So you can do that easily without having to load all the data, having to rescan every time, and you can get to where you want to go much sooner and easier, and you know what you're creating. If we go to grids, again, let me turn the grid on. For a grid, what you get is a bounding box. So we've not done anything to the source data again. The grid is here, and if we look at the view the metadata, it tells us the bounds of it, the projection, and the rows and columns. So a summary information of that. Then you can decide whether it's in your bounds or whether you want to import it, whether you want to do other things to it to resample it and those sort of things. Similarly, for images, we've got a bunch of images here. And again, one of them, we've got a folder of aerial photographs. And in this case, there's a bunch of TIFF files. These are half-meter aerial photographs for the area around Portsmouth. And we just got those on the disk, had no idea what they were. You can tell sort of from the way people used to identify that was from the bottom left corner, easting and northing, and they're 2.5 kilometre squares. But now you have that on the screen, and it's much easier to decide and say, okay, well, I actually want this one, and I want to convert, if we turn my other grid off, if I want my aerial photographs, I only want that one, and I want that one, and I might want to convert that into an SD file. Okay, so in that question related to how bigger images can we import, part of that solution is you don't need to import all of these here. You can only import the ones you want, and if necessary and you still want to do something to that image, if you want to resample that, this is where you do that within DMagic. You can go and edit the image. And as I say, this is editing the source data. It's not an SD file that we've already created. So we load that image up into the image editor, and it loads it up, and here's the aerial photograph into Portsmouth. And then there are the other tools here to look at the georeferencing here, to reset it. You can reproject it to somewhere else. You can make a selection within here, crop that. You can resample down. So this is actually working on the TIFF file, and when you save it, it saves it back into a new GeoTIFF file in this case, and you can write a TFW. So let me close out of that editor, and I'll comment on that at the end and get out of there. Again, within if we turn those off, we also do have the raster chart. That came from a folder. In that case, we have the whole chart of the area, and I did crop that out, and that was the one you saw previously in the Fledermaus view. So here we have now the crop chart within the main view. So now all of these data are up in the source data. They haven't all been converted, and you don't need to convert all the source data, but it provides you of a management where that is, and you can then do work on top of that in preparation for using Fledermaus. And again, if we want to bring on the vector of the bounds, the yellow bounds now of the S57 coastline is shown, and we've already converted that, and you're seeing the coastline in the scene. Okay, at this stage, if you do want to bring in other source data, you have the option of just from the file menu adding the source data there, or you can come to each type of object and say, okay, I want to just add more of that type. So if I add that, I can say I'm interested in a file. I'd like to add the, I had a DXF file thing here. Let me just go back. Sorry, let me just go back to my my external drive, sample data, and there was a DXF file of the coastline as well. So I can say, okay, normal thing, what is that coordinate of the imported data? That's actually WGS84. Didn't have it in the DXF. We can bring it in, and you'll see what that was. This was the coastline from the other file. So we can say this was further up the river, and if we want to now say, I want to convert that, we'll convert it to an SD file. We'll bring it in, and now we've got the coastline SD file is down the bottom. You still see the bounds of the DXF source data, but now if we turn that off, you'll see that goes, and we've got the converted coastline down below, and that's a standard line object that you can then use in Fledermaus. Okay, just briefly, and again, of course, any of these sort of things, as I said, once you're here, then it's a matter of being able to go to select on any of those objects. If you want to directly load the coastline within Fledermaus, now we can pick this one, and you can either launch Fledermaus or you can double-click. Brings up Fledermaus, and then you can start to load all of those other, to build a scene separately as you did before. So here's that object. If we then want to look at some recent objects, we can then start to build the scene directly, same way as we did before. And again, this is WS84. We can actually change the scene coordinates now. Back to UTM-19. You'll see the grid is the UTM-19, and that coastline automatically reprojected into that. So then after that, it's the same as before. You're then using Fledermaus in the normal way to analyze your project, process whatever you do. So if you're one of those that have you need to build a PFM file or those sort of things, from within Fledermaus, you can drag through here, right-click, build a PFM file. It will select the data you can use or not use cube processing, and then begin to walk through the steps. And again, automatically knows what the original data is. The output coordinate system has the flow of the project coordinates, and then the standard thing knows the bounds because you selected it graphically, and then normal, as per normal for a PFM build. And once it's built, you're off to use it in Fledermaus. Okay, Erin, any questions there?
Okay, we did have some last time. I kind of zoomed through it. If you had a question and I missed you last time, please raise your hand again. I'll give it a few more minutes this time. Sorry about that. In the meantime, there were some text questions that we answered offline, and just to go through those for everybody else. Jim Thompson asked if you could turn off a texture that was draped on an SD like you could in version 6. The answer to that right now is no. You have to, if you want to go back and forth between draped and undraped, I find it easiest to have 2 copies of the SD, though that is frustrating because it does take up more memory. But that used to be in 6, and I hope we'll bring it back. And Jim, I'll try and find out a little more about that for you. Nicola asked, what is a PFM and why would you use it? If you have never used a PFM, it's a specific type of object in Fledermaus. It looks a lot like the normal 3D surface, but it has access to the underlying soundings or the Lidar points if you're using Lidar data. So you use a PFM if you want to do editing on the surface, if you're cleaning your multibeam or Lidar data, or if you're just doing QC check. And Lindsay's loading up a PFM there. So as I talk, you can kind of demonstrate what a PFM looks like. So you would build a PFM if you are cleaning data or if you are doing quality control on somebody else's cleaning. Nicola also asked, how would you know cell size? You can in DMagic plot the points to estimate points per cell. If you're not familiar with doing that in DMagic, we're going to have a DMagic webinar in September, or Lindsay can also kind of demonstrate that quickly while I'm talking. And then Nicola also was more wondering what you should use as an estimate of points per cell. And I personally don't know that. I know you need 1 point so that you don't have a hole, but other than that, you want to make best use of statistics. Lindsay, if you have any suggestions on that, you can jump in. If not, Nicola, I'll look that up for you and I'll send you an email.
I think it depends on your purpose of building that surface, and whether you're at the stage of trying to highlight artifacts in the surface, or you think it's complete and you're trying to build a best estimated surface of the seabed for ongoing analysis. And really it needs a knowledge of how the data was gathered, the sort of type of sonar footprint, which depth of water and all of those sort of things, type of sonar. And then what we're trying to show here with that particular data was to say, in this area, if I just chose one line and said plot the selected data points, oops, sorry, let me zoom right in here. What we're saying is this is a 1 meter cell size, and looking at replotting that, you'll see, I don't know whether you can see that on the screen, within this range of the data, if I just make that a little bit bigger, you'll see within these cells at 1 meter we're getting, 5, 6, 7 points per cell, and they're obviously overlap. Maybe you can drop that down for that depending on what you need to do. And that's the benefit here of what we see, is that you can do it here, but it's very easy to just say, well, let me try that, and let me get out of the plotting here. Sorry. And at this stage you can, let me just get back here. We're done. You can go in there very easily, and just in a small area you can say, well, let me grid that now, and I think it's 1 meter. Why don't I try that? Here it is. Then I can say, well, let me do it at 1 meter. What weighted field diameter do I want? So I've made 1 there. So I might try that at 3, and so this is how much it interpolates over. I can do it at 1 meter. I can do it easily, just quickly run that through, and this is sort of like, test 3. Run it through. You can grid the data quickly, and it's processed and does that, creates a grid, and say, okay, well, that was okay, but let me just try that again. Okay, let me make it half a meter, and maybe I'll make it 0.5. So those sort of things in a small area. Now you don't have to grid your whole data set. You can just very quickly, you can just very quickly run through and check it and see what the variations are in each of these data sets. So that was one of the things, that you can just concentrate in an area, and really it's trial and error, and to best estimate your requirements at the end. Okay, sorry, that's a long answer, Aaron. Go on.
It's okay. And by the way, we are running a little bit over time. If you have to leave, feel free to leave at any time. For the rest of you guys, we'll just finish up in a few minutes. But another question from Nicola was, are GSF files clean or not? And that depends. GSF files are just a multi-beam file format type, and they may be clean or they may not. If you don't know, that's a good time to use that simple workflow, and maybe just bring a couple lines into Fledermaus first, and if they look messy, then you might want to PFM them. So that's a good example of when you might just want to use Fledermaus to quickly check a line. Let me just check my hands here. Gabriella did have a question. Let's just take Gabriella off mute and see if she still has a question. Gabriella, are you there? Gabriella? Do you still have a question? I'm going to guess that's a no. So, Gabby, if you do have a question, just hit me back. And Jim, if you still have a question, just raise your hand for me and I'll get you. You are on a phone, though, so I'm not sure if I can get you in easily, Jim, so it might be easier if you have any other questions to text us. The last thing is Lindsay's just going to go through when you have to either use Fledermaus or DMagic, so we'll finish up with that, and then the last thing I'll do is just do a quick summary of what's coming up later. So I'm going to give it back to Lindsay.
Okay, thanks, Aaron. So having said that, simple workflow is really all within Fledermaus, and then the more complicated project management workflow of keeping your data, source data organized, and those within DMagic, there are some things that you can only do in one or the other. Some of those are being rationalized where it's appropriate, so they'll be in both, but others will probably stay separate. Within Fledermaus, I didn't show that, but you contour data, that's done on a surface object within Fledermaus surface differencing. You can reproject surface objects to another georeferencing system that is currently just within Fledermaus. So if you've got a requirement to deliver, you're working in one UTM zone and you want to deliver to someone else in another zone or it's adjacent, you can do that within Fledermaus. Then you would need to go back to DMagic to export that if it was to go out as, say, an XYZ file. And there's object translation. You can actually move around in Fledermaus and graphically and move them up and down. So say you had a survey that was done and you had a surface of the seabed, and then you found out later on that the datum was wrong and it's a block shift. You can do that directly within Fledermaus now. So that's within there. Within DMagic, as I said, the only place to do image editing. And one of the things I do with that, and people who know us from before, we had, excuse me, we had, let me just close DMagic for a minute. We used to have an image editor, and I'll just escape out of there, sorry. But within DMagic, what I tend to do and what we recommend for people if they're, using and editing images, is I create a image scratch project. And so it's just normally default WGS84, and I just put images in and out of it when I need to modify it. So this was say the chart for Portsmouth. And so I can just immediately use that and go straight in and edit that image to load up the full chart, not the section that I had cropped out before. And once I've done whatever I need to do, I might just want to, crop out that section for this particular project. I can do it, save it, and remember when I save this, it's going to save it as a new new TIFF object. I'm not converting it to an SD. And then once I've got that, I can put it in my project file and use it and convert it. So instead of having to worry about creating a new project every time to do any image editing, we recommend people just have an image scratch project, and when they're finished with that particular one, just close the project. I'm not going to save that, and then you can even just remove that file from it. But the project stays current, and you can use that for ongoing image editing. So if I go back to that for a sec to close off. So that's what we do with image editing. You saw me do the plotting ungridded. You can export gridded, ungridded data from DMagic, and that's one of the things we know people use the tool for, is that they have to deliver an ASCII XYZ file to a client as part of a deliverable. Well, you do that within DMagic. You obviously can only build and unload and do PFM construction and appending in DMagic. The computation of rugosity and slope, interpolation and resampling of grids, that currently is only within DMagic, but I expect that is moving into Fledermaus as well. Okay, so that's and in summary, again, I hope that sort of leads you off into the beginning of thinking about what sort of data you have and what you might be doing. If you really just got a few files you want a quick look at, combining with some other ancillary data to check, do a surface difference, you can get it straight into Fledermaus. If you've got a big project or it's lots of lines that you need to process, regrid, and you don't want to have to then know where, and you want to know where they are geospatially, you can have them all set up. The source data can be in a nice geospatial management, and then you can repeat things, and you don't have to reload the files every time you want to do that. Then you use DMagic. Okay, thank you very much.
Do we have any other questions? You can raise your hand now. And you can keep raising your hand. If you don't have any other questions on the DMagic workflow, I'm just going to flip back to myself for a moment, just to bring up a little PowerPoint slide here. Bear with me. Sorry for the not very professional looking display here, but I just wanted to let you guys know if you have any requests for webinars, either topic or time zone, you can send them to me, ehefron@ivs3d.com. These are the webinars that are coming up. They will be on our website, and you should get an email when the registration opens. We have FM Midwater coming up in August, 2 different sessions trying to hit 2 different groups of people, those in the Pacific and then the rest of us that are on the other side of the world. Fledermaus module, August 25th, that's going to be focusing solely on the Fledermaus module and tools in there. Fledermaus Arcgis Integration, we do have integration coming up with the Esri suite of software, specifically Arcgis. That and the FM Midwater are 2 new bits that will be in version 7.2. The Arcgis integration webinar is scheduled for September. And then at the end of September, we have DMagic. On the horizon, I'm sorry, this DMagic is going to be very much focusing on the DMagic tool and stepping you through building a project and where everything is. So that will be a little more focused on the tools themselves. On the horizon, I do see us having a hydrographic processing cube webinar coming up, and I'm thinking October we'll probably have that. So that one I already got several requests for, and we do hope to have that. But if you have a specific time zone request on that, please let me know. Let me just do a quick check on hands here. All right, I don't see any hands. I don't see any questions. So finally, we are working on getting these up, the webinars that we've recorded up for you to download. And as soon as I have that up and going, I will email you guys, anyone who's attended or registered, and I will let you know. Thank you guys for attending, and I really hope to see you all on some more webinars. Thank you very much.